Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello, everybody, and welcome to this week's episode of the DooDoo Diva Smells Like Money podcast. I have the distinct pleasure of visiting today with two fine gents from E1 Corporation, Chris Greco and Derek Lachut. So, guys, I wanted to bring you on the show because for me, in where we met at the Florida, the Water Resources Conference?
Yes.
I stumbled upon your technology. I was kind of aware of it on the fringes, but didn't really understand much about its applications. I was quite familiar with vacuum sewers and how they operate, but was very intrigued by what you were presenting and offering. And as we got into some conversations, something that I don't know which of you brought it up, but that your technology is not something that is taught in engineering schools as something that should be considered for sanitary sewer for municipal. And so I wanted to touch on that question first. And maybe if you can give our audience, why is that nobody's talking about it, why it should be talked about, and a little bit of, I would say, you call it pressure sewer 101. And so with that, whoever wants to kick it off, have at it.
All right, maybe I'll start, and Derek, you can pick up the back end. But pressure sewer has been around since the late 60s. The founders of our company actually created the world's first residential grinder pump, and then introduced this to the market, created the market. And it was considered an alternate technology, basically use pressure sewer in areas where it's extremely challenging to sewer land. Perhaps if the land is below the pipe that you pump up to. And for many years, that's kind of how it stayed, a bit under the radar for special applications, hard to sewer. And the Clean Water Act really spurred a blossoming of this technology. As part of that, Clean Water Act asked for innovative technologies. And that's really where the spotlight was put on this technology. Gravity sewer has been around for years and years. That's really our only competitor. And, engineers don't get fired for designing gravity sewer. So our technology was seen as an alternate, maybe out on the fringe, not too sure about this pressure sewer type business, but over the years, most, if not all of the good land has already been sewered. So our technology has gone from alternative to today very appropriate, as we're being leaned on more so day in and day out to sewer, whether it's new home construction, septic to sewer abandonment projects, or rehabbing any failed competitors' pressure sewer system. And unfortunately, again, it's just not taught in schools where a lot of our engineers are coming from school. So it's a big challenge. We have to educate continually, day in and day out.
And on that note, why isn't it being taught in school? It's something we're still trying to figure out. And as the originators and the innovators in the industry, we do have outreach. We have a career curriculum that we've developed. We have worked with some local schools, universities, trade schools, 2-year schools, just to make ourselves available to help educate the market. And a lot of what we do on a day-to-day basis is, again, that outreach, that proverbial missionary work to continue to educate. The earlier that we can educate the up and coming engineers, the future decision makers, the better. Our messaging isn't that this is the only solution, but this is a very appropriate solution in some some challenging and not so challenging applications. Chris described a lot of maybe some geotechnical issues, but the other problems that our systems can help solve, problems that are relevant in the industry, are things like inflow and infiltration, things like identifying abusers that are putting non-organic debris into the sewer system. Our systems can help identify those issues. And so again, it'll be a perpetual mission, but we will continue to cast a wide net and try to educate as many people we can about just the existence of the concept in general.
Yeah, and pressure sewers, it's pretty basic, a concept that our founders created as a spin-off from General Electric. We have an appliance, much like a refrigerator or disposal, sit buried in front or on the side of a home or light commercial type business. Wastewater is going to flow in through the lateral. The basin will fill up with wastewater. Our pump will recognize when to turn on, macerate, and pump the wastewater out over a small diameter pipe. One of the biggest differentiators with pressure sewer is we like to use small diameter pipe, 40 mil, 2.5, 3, 4 inch to achieve scouring velocities. Smaller pipe means significantly less in cost from an installation standpoint, from just a material purchase standpoint. And with pressure sewer, you can put the pipe where you want it to go. Whereas with maybe gravity sewer or even vacuum sewer, you're a little limited to more grid-like traditional collection systems. So very flexible and also a very light touch on the land. Really what we're going to market with is providing an environmental quality of life. We're in the business of cleaning water in a very economical and less invasive method than gravity sewers, for example. So that's just a quick highlight. Derek and I could talk about this stuff for hours.
Right. Well, when you were saying about less expensive, so let's say you've got a city that is looking to put in new subdivisions that doesn't have the geotechnical or those challenges. It's just straight wanting to tie it in to the rest of the system. What advantages do they have in asking the developer in laying in those lines over the traditional gravity sewer? And that gets me back to that question. Is it perhaps people don't want to specify it because they don't understand it, and when it's something new, it's a little scary? Could that be part of it? But then what are the advantages, like getting back to that, to the advantages of a city saying to that developer, we'd like you to do this instead? Does it help the developer cost-wise as well as the city?
Most definitely. In fact, we've got about 16 of our distributor sales folks here for sales training for 3 days. And today we spent some time on the value proposition, particularly for the builder or developer. One is the upfront capital expenditure could get reduced anywhere from 50, I've seen 70%. We're able to eliminate or minimize the number of lift stations needed in a development. That's a big chunk of the cost. In addition to that, we can create lot density or provide the builder to provide or offer more product so they can maximize that piece of land. using our technology, builders or developers can install a collection system much faster than any of the others out there. So we can create speed to market. We can help builders evaluate land to determine if that's a wise investment. We have an application engineering team who can work studies up to provide cost estimates. And there's other tools on our website. Maybe Derek could talk to the municipal sanitarian side.
Sure. Oftentimes, the municipality might just see something that's different as just the developer trying to save money, but there are real tangible benefits for the municipality. Some of the obvious ones I've mentioned a little bit earlier. Prevailing issues with municipal wastewater collection systems are inflow and infiltration. Right. And again, those non-organic debris that ends up in the sewer system, creating issues. So from an inflow and infiltration standpoint, the pipe network of a pressure sewer system is generally sealed, resistant against infiltration. In a gravity system, oftentimes direction changes incorporate manholes. You have large diameter materials, often more brittle materials. Over time, these materials break down and allow groundwater, stormwater, surface water into the sewer system and creates that peak wet weather flow. It burdens the network, increases the cost to support and treat all that infiltration, can contribute to things like sanitary sewer overflows during wet weather events that create public health issues, environmental issues, those sorts of things. The sealed nature of a pressure sewer system practically eliminates that inflow and infiltration. So from the municipal sanitarian standpoint, not having to worry about all of those issues, and maybe it's going to allow that development to go forward if the existing treatment plant, say, doesn't have enough capacity for that traditional gravity system with all that extra infiltration. We're actually just providing, we're just transporting the actual wastewater that needs to be treated. From a non-organic debris standpoint, I laugh every time I say that phrase because we all know what the organic debris are, but these are the baby wipes, these are the diapers, these are all those sorts of things that contribute to that.
Wipes.
Right. In addition to that, there are the organic things like fats and oils. So it's this fats, oils, greases, and all those other debris. Those are plaguing wastewater systems around the world. E1 has projects in 44 countries, and I guarantee you, of all 44 of those countries, they're all struggling with infiltration and debris in their wastewater system. So this isn't just something that's a problem in the U.S. or North America. It's around the world. Grinder pump stations and pressure sewer systems can help identify the source of those problems. Chris had mentioned earlier, a component of the system is a grinder pump. It might be obvious that that grinder pump is intended to grind that wastewater. But look, at some point, there could be a problem, and there could be a problem at that grinder pump station. But the real benefit to that is the municipality knows where the problem is, and they're able to address that problem. And more importantly, they know the source of that problem. They know which connection is contributing those flushable wipes, non-wipes in this case, the fats, oils, and greases, and they're able to address that problem at the point source. Oftentimes, these problems that are occurring in traditional systems are occurring somewhere in the pipe network or at a pump station that could be serving tens, hundreds, thousands of properties. So it's anyone's guess at the actual cause of those problems. So those are two of the obvious ones. Another one that I often like to bring up too is because pressure sewers and the pipe network doesn't have any slope or grade, oftentimes the burial depth of the pipe network is very shallow. And when we talk about the burden or the need from the municipal standpoint, they're going to own and maintain this pipe network for the asset life, 58 years, maybe 100 years, depending on the material that's used. So the shallower something is, the easier and safer it is to maintain it in the event that some sort of service is required. we see lots of gravity sewer systems, especially in flat areas and different topographies, where you are seeing, for repairs or cleaning, you're seeing excavations that might be 15, 20, 30 feet deep in order to access these different areas. Not only is that expensive to do all that excavation, very disruptive to the community, but it's very, very dangerous for those sanitarians that have to, do that actual work. So if a municipality is able to prevent that from happening, have all their utilities be as shallow as possible, it's addressing cost and it's reducing risk. So just a few examples of some of these benefits.
Right. Well, that leads me to that question, because I'm sure it would come up in a municipality's mind is, okay, this is a new system. I've always, I'm familiar. I know how to deal with, VCP gravity systems. This is something new. What am I going to be looking at from a maintenance and operational health standpoint? What are the burdens of this versus something that I already know? Am I going to have a learning curve? What's going to be the burden on me if I decide to go this route?
Yeah, great question. And, we talk about what those barriers are for wider acceptance of pressure sewer. And I'll just be completely honest, when people learn about this system, they hear that the system is powered by grinder pumps, and immediately they think that this is going to be some massive operational burden on them. And we like to create or address some of those myths and misconceptions. First off, we'd like to reiterate that the concept was first developed as a household appliance. This is the founders of E1. This pedigree from GE was that this product was a household appliance. So we think of the maintenance interval, if you will, of other household appliances, your dishwasher, your refrigerator, those sorts of things. A couple of things, we intend for there to be a long service time between services, and also no preventive maintenance. So when we start to differentiate a grinder pump station in a low pressure sewer application from what most municipal sanitarians are familiar with when they think of a pump station, one has no preventive maintenance and long periods between service, and one requires constant service. That pump station might have routine maintenance and things like that. From E1's perspective, again, as the originators of the concept, we've always believed that the system should be simple to operate, and should be built for longevity. Like E1 has over 800,000 units now in operation, and we have documentation of a mean time between service calls between 8 to 10 years. So these grinder pump stations shouldn't need service routinely, but every 8 to 10 years. And we work closely with the users of the systems to create operation and maintenance plans. We leverage our existing users when we have a new user to help create some realism on what the labor burden is going to be. And I use the word burden, but oftentimes it's not. Anecdotally, there are systems that incorporate 1,500, 2,000 E1 grinder pump stations within a pressure sewer system, and may only have 2 or 3 service technicians to operate that entire network. So it's really not this large maintenance burden. Don't let me fool you. There is maintenance that's required, but it should only be 8 to 10 year service interval.
So how does it integrate, or I like to use the term play nice, with an existing gravity system, like a new subdivision coming online, or maybe a section of the town that has been septic that they now want to put on public sewer? Because you mentioned something, and I'm just trying to picture this in my mind. If it's a closed system, if you have to access it for repair, how is that done? Or how does it tie into a gravity system where there's manholes and deep buried lines?
Yeah,
visually, I'm having a hard time wrapping my head around that.
The pressure sewer system itself is closed. We don't let the bad stuff out, or obviously any of the groundwater in. we're a collection and transport system primarily, so we always have to discharge to something. That could be a manhole, an intermediate lift station. In some cases, it's right to the headworks at a treatment plant. A significant number of our installations are discharging into a gravity system. There are installations where there's both gravity, pressure sewer, maybe vacuum on one end, or a different combination of either. So we're very agnostic and can play nicely really with any technology. There are some purists at E1 who believe a grinder pump should be attached to every single home. But at the end of the day, sometimes gravity sewer or another technology might be more appropriate. And if it's an application that won't bode well for us or the customer, we're going to make that recommendation. We've earned a trusted advisor status through the years, and we want to keep that because our only product is pressure sewer here at E1. So if we're going to do it, we want to make sure we do it very well. Otherwise, we'll have reputational concerns.
Is installation performed purely by your company, or is this done by sewer service contractors?
So E1 will manufacture our distribution chain, or our authorized network will sell and service. And typically installations done by a contractor or underground earthworks organization. If a community is looking to move away from failed septic, they'll bid the work out for installation, and we will work directly with the installing contractor, certify and train their staff. They typically do all the earth moving, etc. E1 and our certified distributors will be able to provide training, startup support, commissioning support, etc. So there's definitely multiple stakeholders who are going to work together for potentially 10 or 15 years or longer, like some of our existing projects.
And I'll just add on to that, because E1 manufactures the entire system, not just a grinder pump. We manufacture the entire system. We have designed the system purposely to be as easy as possible to install. So it's not complicated to install a E1 grinder pump station because we've made it so. And in addition to that, Chris had mentioned certification. We offer a certified installation training, whether it's a large municipal job, a septic to sewer job, or individual contractors, excavation companies, plumbers, those sorts of agencies are capable of getting E1 installation certification through a training program, through online training systems that we have. So we try to accommodate as many users as possible. We want to make that training, that information as accessible as possible, because we have seen firsthand that the longevity of the system, reliability of the system can be directly proportional to the quality of the install.
Quick question for you, and not that we want to do a comparison or this is better than that, but just those distinct differences or maybe similarities between a pressure system and a vacuum system, a vacuum sewer system. Because it sounds like there's the principles behind it are similar, but are there distinct differences so people understand what that is?
Yeah, so a gravity sewer system and a vacuum system kind of operate off the same principle. There's central equipment that serves, the homes or businesses. And in those cases, typically a fault at the lift station or the central vacuum station means there's going to be a fault with all those being served on that connection. With pressure sewer, a fault at one site does not affect the operation at any of the other sites. That's probably the biggest advantage. The second biggest advantage from an economical standpoint, you need a certain number of connections on a vacuum sewer for that project to have some type of good return on investment. That's not the case with pressure sewer. It could be 1, 10, or or 10,000 units, and you're still going to realize the technological and economic value that we can bring.
I've heard about some things with vacuum sewers where they've come a long way. When you were saying about the one station would go down, that now with these, I was going to ask if you had a system like with these telemetry systems that they can actually spot if one house's, I guess, what do you call it, the pump station,
An alarm.
The pit starts to experience a problem, it won't affect anything else that might be connected within that at that station, so they can isolate it. Do you have a similar system for telemetry? Because you were saying earlier that you could actually pinpoint if there was a problem or I.
Well, Derek's team created the product, so Derek, you should talk about that.
So there are telemetry systems that are available for E1 grinder pump stations that can do the very basic to provide indication if there's a pump fault, but where E1 monitoring systems can be a bit more advanced than, say, a vacuum sewer system telemetry system, as we start to gain some analytics on individual pump cycle times, when the pumps operate throughout the day. We're able to do some predictive indication of where there might be sources of infiltration into the system, when do some predictive maintenance on when a grinder pump is operating, because we see how often, how many times a pump has cycled, how long that pump is open, or excuse me, how long that pump is operating. So, there's a lot of functionality and telemetry and big data are really starting to become part of pressure sewer systems, but all sorts of wastewater collection systems. Real quick, I just want to add one of the other key differences with a vacuum sewer system and where pressure sewer systems can perform a bit better. Vacuum sewer systems have limited static lift or elevation changes. Vacuum sewer systems are frequently found in flat coastal areas because oftentimes you don't have much static lift. Pressure sewer systems, just because of the hydraulic nature of the grinder pumps, are often capable of more elevation changes. For example, an E1 grinder pump is capable of pumping over 185 feet of head, whereas most vacuum stations are limited to 10 or 15 feet of static lift. So you see a lot of E1 grinder pump or E1 low pressure sewer systems in undulating terrain, even in mountainous areas, whereas a lot more vacuum systems are found in those coastal areas. But I'd be remiss if I didn't say E1 sewer systems are also appropriate in those low-lying areas as well.
Yeah, it sounds like these different systems have their sweet spots of where they can really solve difficult issues, so that if you were to pick like those tough terrains for your technology, what would it be ideally suited for? Where you can make a real difference. I think like over a gravity system.
Yeah, again, we often say that pressure sewer systems are appropriate in flat, wet, rocky, and hilly areas. Okay. So to pick one of them, it would be a bit difficult. But you're absolutely right that the pressure sewer systems aren't the end all be all. Chris commented earlier that oftentimes we see hybrid systems because many cities, one technology isn't necessarily the most appropriate in all cases. Oftentimes, cities have different problems and there are different challenges in different regions. So it really comes down to what I would always say is it's a financial exercise or a total life cycle cost exercise. So let's consider the capital costs. Let's consider the operational costs over a normal life cycle, whether that's 20, 30, 50 years, and determine what's the best specific technology. We are an arrow in a quiver. We are a tool in the tool bag for the engineer, municipality, for the land developer to figure out the most cost-effective way to provide service to their stakeholders.
I'll just add to what Derek said, though. Today, the technology acceptance is gaining at a much faster rate. And primarily that's because most of the good land is already been sewered. So what's left over, you do typically have a lot of challenging terrain. And what a lot of our customers are telling us is a municipal budget for gravity sewer is just not able to meet the need for that particular challenging site. So what's left to be sewered really plays right into the E1 sweet spot, which again is rocky, hilly, flat, or wet. Budgets are getting tighter, and in many cases, we can significantly increase the number of connections with the pressure sewer system than a gravity system, double in some cases for the same budget type of project.
Is it applicable for multi-unit dwellings like high-rise condominiums, apartment buildings, things of that nature?
So we really operate on the lower flow end. 11 gallons a minute is really the sweet spot, up to maybe 40, depending on the product configuration. If it's a high-rise building, that's really not an area we're going to play in. That would lend itself to vacuum or gravity.
Okay.
But from a light commercial side of things, within we often see a lot of commercial applications within larger residential communities. So, back to our example that we've been discussing about new land development, oftentimes it's a bunch of single family homes, as well as maybe a school or a church or businesses. We have stations that are configured to handle really a lot of those sort of things, whether it's a hotel, whether it's a school, restaurants, those sorts of things. At a certain point, like Chris was describing, once the flow becomes too great, once the total daily flow becomes too great, we do start to struggle, or there's other approaches that we need to look at. Instead of having a single grinder pump station serve a single building, we might look at splitting the flow in a building into 2 stations and things like that. There's a lot of techniques. There's a lot of different building types that we have serviced with grinder pumps, but we're not doing much work in Midtown Manhattan, servicing the Chrysler building or anything like that.
Okay. Well, this sounds like it is definitely an alternative, and I don't want to say an alternative. I don't like that word. It should be considered just another mainstream choice at this point, depending on your application, not as well, maybe we'll do that if this doesn't work, that it should actually maybe be given first pass consideration, comparing apples to apples by more municipalities and developers. Obviously, like Chris was saying, it's not going to be the perfect solution for everything, but it definitely sounds like it's got a wide range of applications that people may not have been aware of, just because you don't know what you don't know, right? Which is why I have this show, and I want folks like yourselves coming on here to let the world know, hey, have you ever thought about this? And if you haven't, maybe you should. So I want to thank you for sharing that. And for those of you who are interested in learning more about this technology, you can reach out to these 2 gentlemen on LinkedIn and find out more information on their website. And that information is coming up on screen and is also it's also included in the show notes below. And again, to both of you, thank you for sharing your time with me and, explaining to I've been around the industry since 1998, but I had very, very little knowledge of this. So thank you for bringing me up to speed and giving me a lesson on Pressure Sewer 101. And thanks again. And
thank you.
Yeah, I look forward to
It's been a pleasure.
seeing more stuff coming out about your application showing up in more and more places.
Very good. Well, thank you so much. We appreciate it. We run into customers or folks that, may be a customer down the line every day. Our company and our folks at the team have been doing this for 53 years, and every day we run into people who have never heard of pressure sewer. So we're happy to spread the word. And again, thank you for having us on today.
Oh, and thank you. Thank you. Well, thank you for joining us on this week's episode And until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.